Okay, so now that we're talking about alkenes a little bit more, we need to talk a little bit about the nomenclature for how to refer to a specific alkene. So here we have a couple of very common alkenes, and so what we're going to do is, just like with alkanes, we're going to be counting the number of carbons in a continuous chain and hopefully trying to maximize the number of carbons in that chain. So here we have 1, 2 carbons, and if this was a regular alkane, we'd call this an ethane. And so what we do is, if you now change the functional group from an alkane to an alkene, it's a very simple transition. So you go from, instead of an ethane, we're going to call it ethene. So we're going to keep the eth the same. So we're going to keep the eth the same, but instead of ane, we're going to end with ene. So ethene. So this is ethene. So for this example, 1, 2, 3, we're going to have 3 carbons, so meth, eth, prop. And we're going to say for this molecule, since we have both an alkene and an alkane, if you have to choose, the alkene gets a higher priority. So instead of referring to this by the ane, the ane ending, we're going to refer to this by the ene ending. So this is going to have an ene ending. So instead of meth, eth, propane, we're going to call this meth, eth, propene. So propene. So this is the common name for this molecule, and it's very common, so we just call it propene. This alkane is a cyclical molecule, and so instead of calling this a 1, 2, 3, 4, 5, 6, instead of calling it a hexane, we just call it a cyclohexane to notate the fact that it's in a ring. So this is cyclohexane. And so if we wanted to go from the cyclohexane and we just include a double bond, the very simple transition is to change this A to an E and call this cyclohexene. So for this molecule, we have an alkene, and if we count the continuous number of carbons in a chain for the parent, we're going to have 1, 2, 3, 4, 5. So the parent is going to be a pent, and since we have a double bond, it's no longer going to be a pentane, it's going to be a pentene. So pentene. But now, to worry about numbering a little bit more, do we start numbering here for 1, or do we start numbering over here for 1? And so the rules are that we want to try to minimize the numbering, just like we minimize the numbers for the alcohols and the amines. And you can kind of think of this double bond as a functional group. So instead of calling this 1, 2, 3, 4 right here, we want to minimize that number. And we want to say that the first encounter with the alkene is coming at position 1. So this would be position 1 and position 2. So we would call this 1 pentene. This would be another example where we have a pentene, 1, 2, 3, 4, 5, and the only difference is that the alkene, the location for the double bond has changed. And so instead of calling this a 1 pentene, we can either number from the left or the right. If we number from the right, the first encounter with the double bond is going to come at 1, 2, versus if we number from the left, the first encounter is going to be 1, 2, 3. So to minimize that number, we're going to utilize 2 as our numbering scheme. So this would no longer be a 1 pentene, this would be a 2 pentene. And it's very important to remember that even though we have the 2, we really are including both carbons that form our alkene in the numbering for the longest parent chain. So let's give another example. So for this example, we have our alkene right here, and we have to make sure that we include both sp2 hybridized carbons, so this carbon and this carbon, we have to make sure we include them both in our parent. So if we started numbering here, 1, 2, 3, 4, 5, 6, 7, 8, 9, it would look like we'd have a nonane. But if we do that, we're only including this first sp2 carbon. So instead of the longest parent being referred to as a nonane, we have to include both of these carbons. So the longest parent chain is actually going to be 1, 2, 3, 4, 5, 6, 7. So this is going to be a heptane. The only thing we have to do is remember, again, since we have a double bond, to change that ane ending to an ene ending. So it's no longer a heptane, it's a heptene. And so what we're going to do is we're going to try to minimize the initial location for that alkene. So this would be position 1, and this would be position 2. So we would say this is a 1 heptene. And so now what we are doing is 1, 2, 3, 4, 5, 6, 7. this whole part is going to be part of our parent, which means that this yellow circle is a substituent. So that what we have to do is count the number of carbons here. So meth, eth, prop. So this is a propyl substituent, and we have to say where that propyl substituent is. And so that means that this propyl in yellow substituent is located on position 2, so 1 and 2. So this would be a 2-propyl, so 2-propyl. So if we try to further divide this 2-pentene, you might realize that you can actually draw this 2-pentene in 2 different ways. You could either draw the 2-pentene like we already have up above, or we could draw the 2-pentene like this example on the right. Now, it's very important to, again, remember that you can't actually rotate that carbon 2 to carbon 3 bond. So it's static. It's just kind of sitting there. So unlike a single bond, it can't rotate. So these are 2 distinct molecules. So the question then is, how do we actually differentiate between the 2? And the way that we differentiate is one extra little prefix. And if we have the 2-pentene with these 2 carbons, one substituent is going down and one substituent is going up. So it looks like this ethyl group and this methyl group, they're kind of pointing in opposite directions. This is given a name called trans. So this is trans 2-pentene. And in this case, if you look at the methyl and the ethyl, it looks like they're both kind of pointing in the same direction. And in this case, we have a cis 2-pentene. So the molecule on the left is trans 2-pentene, molecule on the right is cis 2-pentene. You could also refer to these molecules by a different designation, either trans or cis, or if you wanted to, you sometimes will see these referred to as what's called E or Z. So you could either see cis 2-pentene or Z 2-pentene. And you could also see trans 2-pentene or E 2-pentene.